Okay, in space, how do they use the time zone? Because like, is it like no time up there? Is like people can't age up there or something?
Well,
All I know is when people in space they actually get taller. Is that true?
yeah. Well, not.
By like an inch or
It's
two.
basically it's cheating, getting taller. Because what happens is when you go up into space, so you know your vertebrae, there's like fluid, spinal fluid between the bits of the vertebrae,
Yeah.
and when you go up into space, that fluid lessens. So in effect, your spine stretches out, and you get taller, quote
Oh.
unquote taller, and it's usually by 1 or 2 inches.
1 or 2 inches. Is it like just say
So you're not going to go. You're not going to start on Earth 5'6" like I am, and then when you're in space, you're 7 foot tall.
I
No,
know.
I'm gonna. If I were to go up, I would be like maybe 5'8.5", 5'9" at the most. And then what happens is when you get back to Earth, because the massive difference in gravity affected on people on the ISS versus people on Earth. So on Earth we get 1 g. That's 1 times Earth's gravity.
Mm-hmm.
So your spine is at the normal level compression where your height on Earth. You go
Yeah.
up to space, the fluid between the discs of your vertebrae kind of expands, so you get taller by 1 or 2 inches. And then once you come back, because then you're getting accustomed to what's called microgravity,
Mm.
which is it's not 0 g, but it's less than 1 g. So it's 1.5 g maybe. So the fluid's not affected as much, so it expands. But once you come back to Earth
Yeah.
and return to the 1 g that you were born into, the fluid retracts until your spine is at the normal height. Now, going up and down space, often over the years of space travel, astronauts tend to get back pain issues, which it's a result of the expanding and contracting of the fluid between your vertebrae. Realistically, humans shouldn't experience that, but because we've gotten to the point where we can actually launch ourselves into space, we experience that.
Okay.
But as for the time zone, so the International Space, from as far as I know, the crew on board the International Space Station used the UTC time zone. That's Universal Time Coordinated, which is the time zone in Greenwich, England. So
Oh.
Greenwich Mean Time (UTC). It's what, as far as I know, that's what they use on the space station, and it's also what the time that's used to coordinate every single rocket launcher around the world. Of course, they'll use the local time. So, for example, SpaceX launching out of Kennedy Space Center in Florida will use the Eastern time zone, but they will also use UTC so they can coordinate with everything going around.
Okay.